terrible attempt at whistling. Hello viewers. Welcome back to the Cramp Lab, the only lab in England where we use knives and polystyrene instead of a pestle and mortar. Now you may be asking, why do I do that? That's because a pestle and mortar, I don't own one. So instead we make do with a knife and a bit of polystyrene, which I will now prove to you since I use polystyrene. So, what are we doing today? Well, first of all we're doing is taking these 3 beakers and doing a nice reaction with them. So we have these bath bombs, and because this wouldn't be the Cramp Lab without some hydrochloric acid, we're dropping them into HCl, which could go a bit wrong, could fizz up like crazy, but we live on the edge. So, the reason we have this is because we're going to combine all these, because the dyes might make funny colours. I will probably do 2 of these individually in each beaker, and then all 3 of them into that. So, what are we using? Well, in my box behind me, we have some hydrochloric acid and some water that I probably won't be using. So, prove to you that this is hydrochloric acid, I'm going to do nothing, because the best way to prove it is through a chemical reaction. Now, these bath bombs, I suppose, contain mainly sodium bicarbonate, which is what we used in the last video. However, these also contain a lot of other things and some dyes and some citric acid, although that only reacts when there's water around. And also we're not using the citric acid in this, so impurities, but this is an experiment. What I should do is show you the lovely salt crystals that formed. They actually are quite nice, and I'm an idiot because I put them on a white plate. I crystallised them on a white plate. As you may be able to see, we also crystallised a fly. I don't know how that happened. Anyways, let's get on with it. So, we're going to start with somehow opening these. And I may have to put a little time lapse of me trying to open these. Oh no, I think I've got it. I might just make a jump cut, those always work. While I'm doing this, I might as well remind you of the PPE, because that's important. Safety is important, folks, and I don't want to get sued. So, I'm wearing these gloves, these goggles, and this lab coat. All 3 necessities, really. Although some labs might not use gloves for handling more dilute acids, I do it anyway because I like being safe. And I say that unironically while standing in a garage. Yeah. Anyways, got the final one open, which is slightly harder, as the final one usually is. So this should make a lovely pink colour when it reacts. So we're going to scrape off some powder. Okay, that should be good enough. So I'm just going to pour it into this beaker. See, I was smart. Instead of just dumping all this straight into the acid, which would have been quite spectacular and infinitesimally stupid, I decided to put it into this beaker. So now, what we're going to do is going to do the exact same thing there that we just did there for this one, and I will definitely skip this. Now, unfortunately, my glass stir rod did break in an experiment, so I'm going to have to just swivel it around the cup. It's going to get a bit cold. As I wrongfully said in the last video, and I should have made a correction, I thought the beaker was going to heat up, but it turns out when it reacts with sodium bicarbonate, which is the same thing in here, it actually is an endothermic reaction. There's a bit of science. I was about to say there's a bit of science today, but what we're doing is literally science. More than me. those of you doing GCSE chemistry, which is anyone who's British probably and not over the age of 16, this is kind of a required practical involving sodium bicarbonate, which would have been better explained in the last video, because that was specifically about the chemical reaction between hydrochloric acid and sodium bicarbonate. Although it's a good example of an endothermic reaction. Although it looks like it should be exothermic, it gives off a lot of bubbles, and that's why you can't use bubbles as an indicator of temperature. That's probably better to just feel it. That's a good indicator if you're not trying to be accurate. If you are trying to be accurate, though, use the thermometer. Those usually help. So we should be about done now. They make nice fancy colours. We might get a bit of pink mixed in with this. Just makes it look a bit nicer. Also kind of not a fair test, but we're just going for pretty colours here, not really a fair test. And now we get the final one. No, I really will skip this because this is going to be painful. I've made the Death Star. I'd probably just raise that about the frame as well. So now we've got enough of that one in. I'm going to put a bit more of these two in. Okay, and now I'm going to get the pink one. It should liven things up a bit. Let's mix that around a bit. So we have roughly equal amounts in each container. And now here comes the fun part. Somehow adding the acid in quickly enough without spilling it everywhere. I know. Really fun. So here goes nothing. And I've now realised my slight mistake, and that is it looked really unspectacular, but you get a nice colour change, and we need a bit more acid, I think. Either that or I've messed it up something. Right, you know what, I give up. I put each one in the wrong one, pour a load of acid over it. I get really nice reactions. So this should, if we stir it around, I've splashed it everywhere, not nice. So now we have like quite almost like soup. Of course you wouldn't really want to be eating this. And the best part about that is if you drop those bath bombs in, you know if it's going to react. And the one with all the mixed substances is quite cloudy. So it seems there's quite a bit of an excess of acid in these two. In fact, you just get some really nice bubbling, and it's quite pleasant to look at. you'll actually notice is that these are really cold now because of the lovely endothermic reaction that happens between hydrochloric acid and baking soda. And we're actually going to test whether or not these are still extremely acidic with my trusty litmus paper, which I've put in the middle of nowhere. So even though the dye is pretty much completely inert in this reaction, it gives the liquid a really just lovely colour to look at, and it's a very good way of visualising the reaction. So we're going to test the pH, because I hope to God it's alkaline. Oh, it's acidic. We haven't neutralised all of it. Great. I may have put a bit too much acid in there. That is completely my fault. So that will probably corrodate in metal. I'm going to go get some hydrochloric. Thanks. Hello. Welcome back. This is now the next day, and I got some sodium bicarbonate to neutralise all these solutions, so we should get some nice little reactions going. To prove to you that this is a nice full little bottle of this. I don't know what I'm proving it. Anyway, so we're going to drop a little bit in. Get some nice fizzing, because we need to neutralise all this acid. Then, if we stir it slightly, should get a bit more of a reaction going. As you'll see, it's bubbling quite a bit. It's quite a pretty reaction. Now I believe the mixed colour one here, which has made a really nice green colour, it's actually almost completely neutralised now. And as you can see, when we add all this bicarbonate, there's barely a reaction happening. However, these two aren't actually neutralised yet. As you can see by all the bubbling, we add a bit more. And I think that will soon be neutralised. So, what have we learned? What have we learned from all this? Well, not only that you can make lovely colours, right? But also that it's really easy to put too much acid in and then have to use 2 tubs of bicarbonate to neutralise it all. So what's the last thing I'm going to do? Well, we're going to mix the colours. So this part is completely unnecessary, but it looks cool. Ah. Just don't fail at pouring like me. And I'm going to put this one in. And finally, this little red colour. It should make a really nice colour. It makes a kind of pink colour, and just get nice. And you get this really nice light pink. It really adds a nice colour to it. So, what have we done? Well, we've done not only the reaction between sodium bicarbonate and hydrochloric acid, and a lot of it, we've made sodium chloride solutions, we've accidentally added an excess of bicarbonate in all of these, and finally, we've made something that looks really nice. I've been Cramp George. This has been the Cramp Lab, and we've made some pretty colours today. Bottoms up. drinking that, Jesus Christ.